In this video, we'll learn about the formation of impedance bus matrix using MATLAB. So we'll do the theoretical calculation as well as the practical implementation of formation of Z-bus using MATLAB. So let's discuss about the concept, that is formation of Z-bus. So in order to form the Z-bus, we require a power system network. So we are considering a two-bus system, which generator 1 is connected at bus number 1, generator 2 is connected at bus number 2. So generator 1 contains an impedance of J0.4 and generator 2 contains an impedance of J0.8. And a transmission line is connected between bus 1 and bus 2, that means in between the generators, which it contains an impedance of J1.2. In order to form Z-bus using the building algorithm, we require a network graph. So we need to draw the graph. So considering the 0 as reference bus, so this 0 indicates reference bus, and this bus is nothing but any element which it is connected with respect to ground. We are going to draw that respective element to this reference bus. So that means generator will have also a neutral grounding, the generators 2 will also have a neutral grounding. So therefore that respect to generator impedance we are going to draw with respect to reference bus. So that means there is an impedance from bus number 1 to bus number 0. So this indicates bus 1 and the impedance of the generator 1, that is J0.4. So this element contains an impedance of J0.4. Okay. Similarly, from reference bus to bus number 2, which it is an impedance of a generator 2, which it contains an impedance of J0.8. And also there is a transmission line connected between bus 1 and bus 2. So draw a line between bus 1 and bus 2, which it indicates with an impedance of J1.2. So all the impedance values we are assuming it as in terms of ohms. Okay. So for this network graph, we need to form the Z-bus matrix. So in order to form the Z-bus matrix, we will learn about what types of modifications will be available to form the Z-bus matrix. So it is very important to know about the types of modifications. Now look at the types of modifications of Z-bus. So we have here 4 types of modifications, indicating as type 1 modification, type 2 modification, type 3 modification, and also type 4 modification. Okay. So type 1 modification indicates that, so this is a type 4 modification. Type 1 modification is nothing but addition of an impedance element between which bus to which bus. That means type 1 indicates new bus to reference bus, type 2 indicates addition of an element between new bus to old bus, type 3 modification indicates addition of an element between old bus to reference bus, type 4 modification indicates addition of an element between old bus to old bus. That means between 2 old buses or between 2 existing buses. So for these conditions, for this addition of elements, what will be the Z-bus modified? So how the Z-bus modified in case of these 4 types of modifications? In case of type 1 modification, the Z-bus modified will be like this. That means Z-bus old will be your old bus matrix, old bus impedance matrix with respect to all the 0 values and ZS. So ZS is the addition of an impedance element. So that means this value. So which element you are connecting, that respective element impedance is ZS. So in case of type 2 modification, which it is an addition of an element between new bus to old bus. So this one will be your old bus, Z-bus old, and this is actually the modification of Z-bus in case of type 2, that is ZNN plus ZS. Okay. So here we are going to not represent with zeros, but we are going to represent with impedance values, which these impedance values will be available in this Z-bus old. Okay. Coming to type 3 modification, addition of an element between old bus to reference bus. So this means Z-bus old minus 1 by ZNN plus ZS, ZG. J is nothing but an old bus number, column into ZJ row. In case of type 4 modification between 2 old buses, Z-bus old plus 1 by Zx, Zj minus Zk, column into Zj minus Zk row. So this is about the 4 types of modifications where the addition of an element is possible. Okay. So by using these 4 types of modification formulae, we can able to form the Z-bus. So out of these 4 types of modification, any one modification will come under each step. Okay. Now just move on to the concept, that is first of all the step number 1, indicate as step 1. So step 1. So in this step 1 we will draw only the part of the graph. That means we'll start with 0, that is reference bus, 2, 1, that means new bus. So this one will be your new bus, this one will be your new bus, and this one will be your reference bus. So what is the impedance element you are adding now? J0.4. So what type of modification? We are adding an element between new bus to reference bus. So what type of modification will it come under? It will come under type 1 modification. It will come under type 1 modification. So in the case of type 1 modification, what it is? JBus old. JBus old means that is the bus value which it in the previous step. So we doesn't have any previous step, so there will be no JBus old. Therefore we are going to write JBus modified as JBus modified is equal to, so this is bus number 1, so indicate with 1 and 1, indicating row and column. And what is the impedance value are connected? Value ZS. ZS is what? This is ZS. That means 1, the ZS is J0.4. So this one will be your ZBus modified at the end of step number 1. Okay. Now coming to the step number 2. So we will add another step, that is step 2. So in step 2 we need to draw also the partial network, that is you need to indicate 0 and you need to indicate 1. So this one will be your previous one. Now I am adding another element between 1 and 2. This one will be your new one. So this bus number 1 will be old bus and bus number 2 will be your new bus now, because this old bus we have used already in previous step. So for that reason bus 1 will be your old bus, bus 2 will be your new bus. So what is the new impedance value in this one? J1.2. That means this is an addition of an element between new bus, to old bus. If it is an addition of an element between new bus to old bus, what type of modification will it be? It will be type 2 modification. So just go on to the type 2 modification formula. Here this one will be a type 2 modification, JBus old, and this one will be a type 2 modification. So just I am writing as it is, type 2 modification. That means JBus modified will be equal to JBus old n by n. N by n means the previous one. What is the previous one? We have only 1 by 1. So that means that is 1 by 1. So that means n will be equal to 1. If n will be equal to 1 means what you're going to get here? Z11, Z11, Znn plus Zs means Z11 plus Zs. So what is this JBus old is the previous one. That means J0.4. So J0.4 will be your old bus. And what is Z11? Again, this one itself is Z11, that is J0.4. And this one is also J0.4. This one is J0.4 plus J1.2. Then what will be the resultant value? The resultant value at the end of step number 2 is, that means JBus modified is equal to J0.4, 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 J1.6 for bus number 1, bus number 2 and bus number 2, because we have used bus number 2, the new bus. So this one will be your JBus modified at the end of step number 2. Now let us discuss about step number 3. So at the step number 3, this JBus modified will be your old bus. Okay, step 3. So what is the network which is remained? We have completed the impedance of an element from 0 to 1 is completed, from 1 to 2 is also completed. Now is pending with 0 to 2. Okay, 0 is the reference bus and 2 is now the old bus. 2 is now the old bus. Therefore, it is addition of an element between old bus 2 to reference bus. Okay, so this will come under the type 3 modification. This will come under the type 3 modification. Then what is the formula in case of type 3 modification? If you see the formula in case of type 3 modification, see here. So this is the formula in case of type 3 modification, that is z bus old minus 1 by zn plus zs. In this case, n is nothing but 2. Okay, j is nothing but a 2. Okay, so zj column into zj row. So now use the same formula here. So then what it is going to become is, I will write the same formula, that is z bus modified is equal to z bus old minus 1 by zn plus zs. Okay, j is nothing but 2, zj column into zj row. Okay, so what is z bus old? Z bus old is the previous step z bus modified. That means j 0.4, j 0.4, j 0.4, j 1.6. Okay, which it is 2 by 2 matrix. Okay, minus 1 by, what is n here? N is equal to 2 because it is 2 by 2. So Z22, Zs is the element which it is added. So what is the impedance of this element which we are adding? That is J 0.8 as per the data. Okay, so if you simplify this one, just, so what it will be? It will be now is Zj means Z2 column into Z2 row. How this will be modified? So this is 1, this is 2, this is 1, and this is 2. So now I am writing this one as, so just write this one as it is, J 0.4, J 0.4, J 0.4, and J 1.6. Okay, so bus 1, bus 2, 2 minus, what is Z22? Z22 is this one, that is J 1.6. What is Zs? Zs is the addition of an element impedance, J 0.8. So the second column, so what is the second column? So this one will be your column of the second bus. So this is a column, right, as it is, that is J 0.4, J 1.6. Okay, you have written the column. Now write down the row. How you going to write the second? This one will be a row. So this one will be the row. So write down as it is as row. That means J 0.4, J 1.6. So just do the multiplication. If you solve this one, what you're going to get? So just this one, write as it is, J 0.4, J 0.4, J 0.4, J 1.6 minus 1 by J 2.4. So you're going to get this one after the multiplication. You're going to get this one as minus 0.16 because it is a multiplication of J 0.4 into J 0.4 minus J 0.16, J 0.4 into J 1.6 minus 0.64, J 1.6 into J 0.4 minus 0.64, J 1.6 into J 1.6 minus 2.56. So after modification, what you are going to get the Z bus modified as, I'm writing directly, Z bus modified as, that is J 0.34, J 0.134, J 0.134, J 0.534. So for this bus number 1, bus number 2, bus number 1, bus number 2. So this is 2 by 2. We have only 2 buses, therefore the Z bus you are going to get size as 2 by 2 only. Okay, so we got this value as J 0.4 minus J minus of J minus 0.16 divided by J 2.4. We are going to divide every value with this one, and we are subtracting this one from the respective value. Okay, therefore you are going to get this result. Clear? So these are the 3 steps, and this is the final step, that is step number 3, and we doesn't have any other network. The complete network we have completed at this step number 3 only. So now we will write all the three steps together. What is the result of step number 1, step number 2, step number 3, and we'll try to write down the program in order to get this impedance bus matrix. Okay, so first we will try to write down the result here. At step 1, what I got, step 1, at the end of step 1, okay, at the end of step 2, okay, at the end of step 3. At the end of step 1, I got as JetBus modified as J0.4. Okay. At step 2, I got as J0.4, 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 J1.6. 1, 2, 1, 2. And at step number 3, I got the result as J0.34, J0.134, J0.134, J0.534. So bus number 1, 2, bus 2. So these are the three results for the three steps. At step 1, step 2, step 3, impedance bus values. That means these are JetBus values, JetBus modified values. Okay, so this is your final impedance bus at the end of step number 3. But while writing the program, we will try to achieve not only step 3, we'll try to achieve step 1, step 2, as well as step 3. That is our objective. We'll verify the result at each end of step. Okay, so in order to do the practical, let us open now MATLAB. So this is a MATLAB, and choose a new value, new script. Okay. So first write down the input data required. First enter as CLC, then after write down what is the impedance value you have choose, Z01. How much is the values you have choose Z01 as? 0.4J. Okay, semi. So next indicate as J12. So what is the value you have chosen J12 as? 1.2J. Give a semicolon. Next Z02. So these are the inputs which we have already discussed here. You can see from the power system network itself, we are taking these values. Here, what is Z01? Z01 is J0.4, Z12 is J1.2, Z02 is J0.8. We need to give that inputs here. Z02 is 0.8J. So now after mentioning the impedance values, we need to display as a step 1, step 2 and step 3. So for that reason, disp command will help us to indicate the display values. So indicate with step 1. So what is the step 1? Step 1 is addition of an element between which bus? Between two nodes. So which node? First of all, between new bus, that is 1, and reference bus. What is the reference bus? 0. Okay, so now close the bracket. Step 1 is addition of an element between new bus and the reference bus. Okay, so it's complete. So go to the next step. So what is the next step? You need to calculate the step 1 impedance bus modifier. So I'm indicating that one with small z, capital bus 1. So this indicates the z bus 1 is equal to, what is the z bus 1? Is nothing but Z01 itself. So make it in a square brackets, that is Z01. So you have completed the step number 1, right? Now again the step number 2. So what is your step number 2? Step number 2 is an addition of an element between. I'm copying this one and I'm pasting here. So step number 2 is addition of an element between. Now this one will become old bus and the new bus will be your 2. So this is new bus 2. We are adding an element between bus 1 and bus 2. So how we are going to do this modification? I'm writing this as Z bus 2 is equal to, so what is Z bus 2? Z bus 2 is Z01, 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 Z01 plus Z12, right? That means just like J0.4, J0.4, same thing. See here, J0.4, J0.4, J0.4 plus J0.4 plus J1.2. Okay, that means Z bus 1 of 1 comma 1, that is the first value, and again Z bus 1 of 1 comma 1, because we have only one value, semicolon, so that it will come into the next row. Next Z bus 1 of 1 comma 1. Okay, next Z bus 1 of 1 comma 1. But we also have plus. In this case it is plus, that is Zn plus Zs. What is Zs? Impedance value which we are adding. We are adding between old bus and new bus. That means Z12. So that will be Z12. And so that means we have completed the Z bus 2 calculation. That is, we have done the Z bus modified at the end of step number 2. Now paste the same thing. That means now we will come to step number 3. Step number 3 is an addition of an element between old bus. What is old bus? Old bus is 2 and reference bus is 0. Okay, so we are writing the program just like how we are doing the theoretical calculation itself. In this case, what am I assuming? We need to write as Z bus 3, but before writing Z bus 3, we are writing as ZZ11. Then after we will write Z bus. So what is ZZ11? ZZ11 is equal to, how we are going to write this one? Just look at here. So because it relates to the type 3 modification, how we are going to write this one, I will tell you. We will discuss. So as per the step numbers, so what is actually we have here? The Z bus old. So what is the Z bus old at end of step 2? That is Z11, Z12, Z21, Z22. This is Z bus old minus 1 by Znn plus Zs into what is the Z2 column. So what is the column here? The column is this one. That means Z12, Z22. What is the row here? Row is this one. Okay, that means Z21, Z22. So if I want to write the value, that is ZZ11, how I can write? First of all, this one, Z11 minus multiplication of this one into this one. That means Z12 into Z21 divided by Znn plus Zs. Znn plus Zs will give you the first element of the impedance bus matrix. Next, ZZ12. So what will be ZZ12? This one, Z12 minus. So what is the multiplication here? Z12 into Z22. Z12 into Z22 divided by Znn plus Zs. So this one is also equal to ZZ21. ZZ21 is equal to ZZ12. ZZ12. So because both are same. And next, if it is now coming to the next one, ZZ22, how you are going to write ZZ22 as the Z22, that is Z22 minus Z22 into Z22, that means Z22, the last one, Z22 into Z22 divided by Znn plus Zs. So this one will be your Z bus 3, which it is ZZ11, ZZ12, ZZ21, ZZ22. So this value is nothing but the resultant value of this one. Okay, but in the program we are writing like that. Okay, the both simplification we are writing like this. Okay, so we'll just write down the same thing what we have discussed now. So what will be a ZZ11? ZZ11 is Z. Here we have a Z bus. So for that reason, Z bus 2 of 1 comma 1, that is the first element, minus Z bus 2, just I will use brackets because of multiplication, Z bus 2 of 1 comma 2 into Z bus 2 of again 1 comma 2. Okay, so the multiplication is completed, divided by Z bus 2 of what is 2 is nothing but 2 comma 2 plus ZS. What is the ZS element? ZS is an addition of an element from 0 to 2. That means Z02. This is an addition of an element. Okay. So by this we have completed ZZ11, which it is same like this one only. So Z11 is nothing but this Z bus 2 of 1 comma 1. Okay. Next, this one is Z12 into Z21 is Z12 into Z21 is Z12 into Z21 or 1 to is same. We will write Z21 itself, no problem. Okay. Next, Z bus 2 comma 2 plus Z02. That means Zn is Z bus 2 comma 2 plus Z02 is Zs. Okay. So this is the way how we are going to write for ZZ11. Similarly, we will write for ZZ22. How we are going to write for ZZ22 is equal to Z bus 2 of this time 1 comma 2 minus Z bus 2 of, it is a multiplication between Z12 and Z22. Z1 comma 2 into Z bus 2 of 2 comma 2. Okay. So multiplication is completed, divided by the same thing what we have written in the upper line, 2 comma 2 plus Z02. Okay, so this is also completed. So Z22 is completed, which it is similar to this one. If you see, if you want to verify Z12 is Z12. Next, Z12 into Z22, Z12 into Z22, Zn plus Zs. That means Zn is nothing but n is equal to 2. So Z bus 2 of 2 comma 2 plus Zs is nothing but Z02. Similarly, we are going to write this as ZZ12 and ZZ21 is equal to ZZ12. Both are same. Next, ZZ22 is equal to, how we are going to write this one? Z bus of 2 comma 2. So 2 comma 2, the last one, minus Z bus of 2 comma 2 into 2 comma 2. 2 comma 2 into Z bus of 2 comma 2. Okay, the multiplication is completed, divided by again the same denominator. That means Z bus 2 comma 2 plus Z02. So we have written 3 steps. So step number 1, Z bus 1. Step number 2, Z bus 2. Step number 3, we need to write Z bus 3. So for that reason, what I'm going to write is display as result. Display as result. Okay, that means Z bus 3 is the final one, is equal to, which it should be in the brackets, that is Z11 ZZ12 semicolon, ZZ21, ZZ22. So this is the way how we are going to write the program. So first of all, we need to give the inputs of impedance values. Then after, we need to indicate the step 1, step 2, step 3 as per our theoretical calculation. Then after, first of all, save this one. Save as ZBus, formation of ZBus. I am writing it as formation underscore ZBus. Save. Now run the program. Okay. So we got one error as, see here. So we have written only ZBus here. We need to write ZBus2 because ZBus is not there. So ZBus2. So we have missed with ZBus2 here. So wherever it is required, write down ZBus2, ZBus2, and ZBus2. Okay. Just if you are clicking on this line, if you are getting any error, so that you can able to verify that one, which line we have done an error. Okay. So now run again. See here. Result. Okay. So rather than this one, we doesn't require also this ZZ11. Okay. So you can make it as a semicolon. If you are giving it as a semicolon, it will not show you in your display page. Okay, make it as a semicolon. This one also make it as a semicolon, so it will not show in a display page. So now again run this one. See here. See, first of all, the ZBus one. So what is the ZBus one here? What is the result we got here? This will try to compare step 1, step 2, and step 3. In case of step 4, at the end of step 1, we got J0.4. How much we got here? J0.4. Okay. In case of step 2, we got has J0.4, 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 and J1.6. Are we getting the same as theoretical? See here. Yes, J0.4, 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 J1.6. We got it is same as theoretical. Now also verify the last step, J0.33. Are we getting it as a J0.33? Yes. Almost same J0.34. J0 here, J0.133, J0.133, J0.533. Here also J0.134, J0.134, J0.534. It is exactly same with respect to our theoretical calculation. Okay. If you are getting any errors, we have discussed how we are going to solve with respect to errors. And if you want a result, then also we can verify. We are going to use the semicolon so that those results are not going to display on our page, so that it will display only the step 1, step 2, step 3 result. So this is the way how we are going to form the impedance bus matrix using the theoretical calculation. And as always, we have verified this theoretical value with the practical implementation in MATLAB using program. Okay. So thank you so much for listening to this session.